Just a little bit about myself quickly. Obviously, I work for EMC. I'm based out of Sydney. Definitely not an Australian accent. I'm from EMC Canada originally, so I've been with EMC 10 years, but been here in Australia 3 years. So my job, basically, on the pre-sale side is to talk to customers like you about how we integrate with the Microsoft stack. So things like we're talking about today. So a little bit on the agenda of what we're going to talk about. On the Server 2012 side, we're going to talk about, first of all, offload data transfer, ODX. Who's heard of ODX or used it? Has anybody actually used it? Not yet. No one? Okay. So we're going to talk a bit about that and how we integrate with that, what it really means to the Server 2012 environment. Support for thin storage. Thin is obviously a very big topic on the storage layer, driving efficiency in storage environments, so reducing the amount of storage consumption. So we're going to talk specifically about trim and unmap. So these are new technologies in the Server 2012 layer that can actually reclaim storage dynamically, which is pretty cool stuff. On the Hyper-V side, how these technologies integrate with Hyper-V outside of, obviously, Server 2012 with VHDX. And virtual HBAs with virtual fiber channels. So some cool stuff there. On the System Center side, SMIS, a lot of people don't know this exists in SCVMM. So the storage management integration that Microsoft built in, which is pretty cool. Some other storage integration points, so rapid provisioning of VMs. And last but not least, finish off with a bit of an eye candy thing, some extreme performance with virtual machines and Hyper-V. So pretty good agenda. This is 90% demonstration and 10% slideware. I'm not a big fan of slideware, so it's good that you're here because what will get posted to the website won't mean much because the videos won't be on it. We were going to do it live, but the network here is a bit inconsistent, so the recorded demos, didn't want to take too big of a risk on that one. If you want to see live demos, you can come to our booth and we'll do them live from there where it's not such a big audience to take that risk. So let's start off with ODX, efficient storage, so offload data transfer. Why was this ever created? What is the point of ODX? Well, the point of ODX is in the modern data center, we're transferring large amounts of data more and more all the time, bigger files, bigger data sets. We need new and innovative technologies and efficient technologies to make that a whole lot easier. What we're seeing is things like SQL Server. Every storage array I look at that's got SQL on it, there's backups everywhere. DBAs love to back up the database themselves to some file system somewhere. So those are getting moved around, which are obviously very large files. And obviously virtualized environments, so moving around VHDs, VHDXs between different LUNs for different reasons. Moving an 80 gig file is obviously going to take a long, long time. So we need some innovative technologies there. These data movements are going to cause bottlenecks, obviously. So if I'm copying a VHD through a network, whether it's fiber channel or Ethernet, I'm going to congest that network. I'm adding extra load to it, as well as I'm adding extra load to the server. So these are all the drivers of ODX. So how does it really work? So it's built natively in the Server 2012. It's a SCSI inquiry type command. So basically, the server will, when it discovers a LUN, it does a SCSI inquiry. Every server does this. And if the storage array supports ODX, it'll respond back, hey, I support ODX. It may not be available on all storage platforms. So the make or break time is probably late 2012, early 2013 that most storage vendors brought out support, if they did, for ODX. Most of ours came out around that time frame. So you want to check the firmware on whatever storage platform you use to make sure it supports ODX. If it doesn't, you don't have to worry about it. It won't work. It'll be a traditional copy instead of an offloaded copy. It's automatically invoked. You don't have to do anything. So if the storage array supports it and you're using Server 2012, it should work. So when you do those copy commands, yeah, that's why I say should. When you do any sort of copy command through Windows Copy API, it will automatically try and do the offload data transfer with that. So basically, it will happen within a LUN, across hosts, across LUNs, and it will actually work across servers with SMB3. So So some pretty cool stuff we can do with that. It's implemented through a third-party copy engine that we call it that starts this whole process. So if we look at it from the SMB3 side, we have two hosts, and I want to move a file across. It basically talks to the other host and says, hey, are you using a LUN that's ODX capable? The host says, yes, I'm using an SMB3 share that supports ODX. It will pass a token, and what a token is a representation of the data it wants to move over. And it passes that over to the other host, and there's an offload read and write token, and the storage array transfers the data in what we call chunks. So they're blocks of data. Every vendor is going to be different on how fast this implementation is, because it's how they've implemented the back-end storage and the chunk size that they're moving the data on the storage array. But the key takeaway here is that whole data movement of that copy operation happens in the storage array layer. So you're not generating all that traffic, whether Ethernet or fiber channel, between the hosts and the storage. So the best way to look at it is look at it in real life. Well, sort of a recorded real life on what it looks like when it works. So I've got a Server 2012 cluster here. I've got a bunch of CSVs, so I got 6 CSVs on my cluster. So pretty standard stuff. On the right side, I have performance monitor. I'm going to start that up. And what we want to show is some counters at the bottom. So bytes transferred per second and disk reads and writes. So I want to be able to show that we're not actually generating any workload on the host when we're doing these types of operations. Basically, I'm going to go to one of the CSVs. I've got a 600 gig file, so a really chunky file. I'm going to simply do a copy and go over to another CSV and do a paste. So pretty standard stuff. And you see here a massive performance, almost 30 gig a second. If anybody was at US TechEd last year, they did this during the keynote, and it was actually on one of our storage arrays, and it was 1 gig a second. We've done a lot of tuning over the year, and now we're getting 30. So pretty amazing stuff. So it's over a half terabyte file in just a few seconds that it's successfully copied over. You can see over here on the right, when I look at the disk reads and writes a second, I know you really can't see the scale and all that, but there's essentially zero workload on the host. So it's just the token traffic, where it's the metadata, where it's initiated the copy operation, and the array looked after the whole 600 gig file on the other side. So I'm going to load it up a bit. I just want to show parallelism with it. So we're going to do another copy and paste. This time I'm going to do 2 at the same time to show that it doesn't fall over. What it simply does is it divides up the bandwidth that it can do. So you see, out of that 30 gig I was getting before, I'm getting around 14 gig a second out of each copy operation. So they can run together quite nicely. You can actually see I started the second one slightly after. So you see the first one actually started up a little higher. As soon as I started the second one, it dropped down. If I started a third operation, likely get 10 gig a second out of all 3. So pretty scalable operation with the ODX copy. See the first one complete here, and the other one will jump right up at the end. So pretty cool stuff on that. And again, you look at the workload on the host, essentially nothing on the read and bytes transferred side, and most importantly, no processor time. So we're taking massive amounts of workload off the host, which means it's free to do other things that are important, like maybe running a database or something like that. So that's just a very quick demo of ODX. Now, what does it look like over SMB3? So we support SMB3. What I'm going to look at here is another host. It's got some various LUNs on it, and you can see some backup LUNs on it. And this is all SMB3, so we're not dealing with block fiber channel anymore. And we have 2 different targets, one that's ODX capable and one that isn't ODX capable. What I'm going to do is open up a file share, and there's my SQL DBA has done a backup. And it's a big backup, so it's 250 gig, so a pretty big file. And I just copied it into the non-ODX capable SMB3 share. And you see there, that's what you get. It's giggy, so I'm getting about 100 megabytes a second, which isn't so bad, but for 250 gig, 35 minutes is a long time to wait to copy that file over. Let's take that same file, drag and drop it into the ODX capable one, and again, I see that 30 gig a second. So it's just the difference between the hardware offload available. And the context of this demo is I've got my SQL DBA who needs to do a quick recovery. He or she can copy that file over. You can see there, 250 gig in my backup ODX mount point. And now I can just run my recovery very, very quickly. So awesome for operational efficiency, this type of technology to speed things up in the data center. So that's a couple of quick demos on ODX. Now you might say, well, how does it operationally behave? Yep.
What determines the thresholds? I mean, what is it the case on the array? Or?
Yeah, so every storage array is going to behave differently. So it depends on how the vendor has implemented the specification. That one there was our VMAX storage platform, so it's fairly high throughput. The VNX will perform almost slightly different. It really depends on the vendor and how the chunk sizes they've used. So it's not defined in the specification. It's how they've implemented on the back end of the storage array. But there's no throttle that you set. It will literally go as fast as it can go that the storage array lets it go. So it's a very, very simple operation. Awesome. Yeah, by the way, I never said that in the beginning. Please ask questions. I'm a pretty casual guy, so interrupt me if you're wondering something. Operational behavior. So what happens when it fails or something goes wrong? Because things always go wrong. So the array can stop an ODX operation at any point in time. So if something happens in the storage array, maybe it gets too busy, a failure, something like that, it can simply drop out of the ODX operation. And what happens is the server just picks up where it left off. So your 30 gig a second will go back down to whatever the throughput would have been without the hardware offload. So in the previous use case, it would drop down to 1 gig a second. So it's non-impactive in terms of availability of the copy operation, but obviously your copy operation will slow down. On the bottom right there, if you do intend on using ODX, this will be in the slide deck that gets posted. A very important hotfix that you should put on the host if you don't have it. Because there were some fixes done with ODX, so very, very important to have. Control. So how do I control using ODX? I said it was simple. Well, it is pretty simple. Volumes can opt out, and what that means is if there's a filter level driver on a storage volume that doesn't understand that ODX SCSI call, it will block it, so it just won't work. And where we've seen this happen is with some older virus scanning software, things like that. So it's not harmful, it just means that you may not, that's why I said before, it may or may not work. There's some things that are in the stack that you can't control. So if it's not working and you expect it to, you have to look at what's in the stack. There might be something that like a filter level driver. So that's opting out, but it's not a tunable thing. It's just what's happening on the host layer. You can disable or enable it. But this is on the host level, so you can just completely disable ODX if you want, for whatever reason, if you didn't want to do that. So PowerShell command there that you can disable it. So that's about it. That's all the tuning there is to it. So very, very simple implementation. And again, this is a Server 2012 feature. This is not specific to Hyper-V, although it obviously can be used for Hyper-V, so it can be used with a native Server 2012 host. Additional uses, as I just said, you can use it with Hyper-V. So VHDX creation, when you create a new VHD file, we'll zero out the space on that virtual LUN. There's something called a write using zero token. So it's basically writing zeros to the LUN, but completely hardware offloaded. So you don't have to wait for that operation to occur. So you create that new VHDX, say it was a half terabyte LUN, you might traditionally be waiting there quite a long time. With ODX, it will literally come back like that because the array is doing that for you. As well, storage migration, live storage migration on the Hyper-V side, so moving a VHD from one LUN to another will get completely offloaded if it's on the same storage platform. So maybe I'm moving it from a nearline to a SAS drive or something like that. The array will take care of that copy with just the regular storage migrate in Hyper-V. So pretty cool stuff there to really drive some efficiencies. So that's some other additional uses of ODX. So just to give a little bit more of a demo on it, so ODX with Hyper-V and SCVMM. So looking here on a library server, and I see a template. So Server 2012 template on my library server. And I just do a properties of that. It's a thin VHDX that you can see at the bottom. So it's 9 gig in size right now, but it's a 70 gig maximum VHDX size. Just go OK on that. And basically what I'm going to do is go over and look at one of my clouds. So I have a dev QA cloud. In that cloud, I have just one virtual machine. And I'm going to go down and have a look at the physical hosts in it. So that one virtual machine sits on a lot of hosts, 6 hosts right now. There's 6 hosts with one virtual machine. So there's my 6 hosts in my cluster. And basically what I'm going to do is provision some more VMs in this cluster. So I'm going to, again, show performance monitor, start that up, and I want to measure throughput that's happening on the host, just to show that there's no throughput. And what I have here is a PowerShell script. Why I'm using PowerShell is because if I template from SCVMM, at least the current version, not R2, it will use bits transfer. It's just the way it works. R2, that's changed, so it will use this. So we wrote a PowerShell script that goes through, discovers the cluster, and it's invoking a command to basically copy a bunch of those, the VHDX from the template library and copy it down to all the CSVs. So what we're essentially trying to do here is show the power of ODX in mass VM deployment, so what it can do. So pretty simple script. It's only about 25 lines. If I go down, line 23 and 24 are really the core of it, creating the new VMs. And we're just going to kick that script off. And it submits it to all 6 hosts in the cluster. So we see that kicking off. And again, we look back over to performance monitor. Same thing as we saw before. Very, very little workload that's going on the host in terms of disk transfer as it's copying those VMs across. And what we're going to do is click back over. This is the best part of using recorded demos because I want to go faster than a demo. After we watch it for a little bit, we're also waiting for the job to complete. So you'll see in the lower left, it's going to give a time on how long that job took for that script. And you can see, I'm not sure if you can read it, but the total time is 45 seconds that it took to run that PowerShell script. And what it's done in 45 seconds is it's copied that template to each one of the 6 hosts. We've done 2 copies to each of the hosts, each at about 8 gig. So we have about 100 gig of data across the 6 hosts, because there's 12 gig on each, that it's literally copied down. I'm just booting up one of the VMs right now. So this is a great example of how you can deploy VMs very, very quickly with ODX and not having to wait for that bits transfer. Not that it's not a good thing, but if you're doing it over a gig network, doing 100 gig of data is going to take a long, long time. So,
is that going to put a lot of load on your storage?
It will put load on the storage array, absolutely. The way I can't comment on all the implementations, but the way we've implemented on our storage platforms is it's a background operation. So it will throttle that operation back if the storage array is already congested. And if it's so congested, like I said before, it could drop out of the ODX operation. So it's a very safe thing to do that you don't have to worry about causing any problems. So great question. So that's ODX. Great offload of disk traffic onto the storage platform. So what about unmap? So I'm sure everybody who uses thin devices, there's got to be some people using thin, yeah. Thin is great until it gets allocated on the storage array. So the catch of thin is I give a thin device to a host. Now, I'm not talking about a thin VHDX, I'm talking about a thin LUN on a storage array, so it consumes space in the storage array as it's written out. What happens is you'll see something like the red line here where you fill up that LUN and you're doing deletes and rewrites and all those sorts of things. And the overall utilization of that LUN, let's say it's 70%, but over time, the actual backend LUN on the storage array will get fully allocated. It's because a lot of the new writes will go into new spots in the LUN, and when you do a delete with NTFS, it doesn't unmap or delete on the storage array underneath. At least it never used to. So over time, you would actually fill up the LUN, even though you were deleting files out of it. So it was thin until it grew, and then it never shrunk. So a challenge within provisioning. Unmap brings that feature to be able to essentially shrink on the storage array side as the NTFS file system shrinks. How is it built? Very much like ODX. So this is a native Server 2012 feature. It's, again, another SCSI command. It sends that SCSI command down to the storage array, and the storage array has to understand it. It's a T10 standard command, so many different storage vendors have written to this. So the firmware of the storage array must support this. Again, probably around the end of 2012, 2013 is the time frame that most vendors should have implemented support if they were going to. So most of our storage platforms do support that as of that firmware level. Again, it's another sort of automatic operation like ODX. When you run a delete on the file system, it will automatically send that unmap command down to the storage array. So it's a pretty automatic type of operation. As well, you can schedule it or run it ad hoc through the optimize option within Server 2012. Again, the best way to see it and understand it is to see a quick demo on it. So if I look at a host, another host here, I've got a bunch of drives on it. So I've got some, they're all thin volumes on a storage platform. I see one's empty, got a few filled up, got some backup volumes again. I'm gonna launch this little tool. It's just a little tool we put together. And basically what it's doing is it's querying the storage array to see how full the pool that the LUN resides in is. And it queries it every, I think it's 10 or 15 seconds we configured it for. So you'll see it start to draw across. And you can see how full that actual pool is on the storage platform. So it's just a very easy way to visualize it as we do different operations on this. Again, we can go to PowerShell. Here we can see, run a PowerShell command to see if ODX is actually enabled on the storage platform. And you can see here that it is enabled currently. If you want, you can disable it through the same command. So now it is disabled. And this is on a host level again. And what we're going to do is go to one of the thin volumes. And we're going to take one of those VHDX files, and we're going to copy it, and we're going to paste it into another thin volume. So put that guy in there. Now, this operation's taking a while because I disabled ODX. Why did I disable ODX? Because I wanted everything to be very instant in the pool level. If the array is doing hardware copy offloads, it would kind of fake out the demo a bit, so that's why I disabled that before. So you see a couple hundred megabytes a second. We had to do some reality distortion because we'd be sitting here a long, long time waiting for it. So sped it up a bit, come back later because we have no ODX on, and we can see the pool filling up, right? It's pretty obvious stuff. I'm copying into a LUN in the storage array. It's filling the pool up. So you see that copy operation finish quite a few minutes later at my 300 megs a second. And you'll see the pool plateau. Now I look at that target. It's, again, 200 gig volume that I'm dealing with here. And what we're going to do with that volume, we just wait for the pool to level off there. You should see it jump across. What we're going to do is take that volume and delete it. So without unmap, this delete operation will obviously delete it out of the file system, but it won't delete anything from the storage array. So those allocated tracks within the pool will just stay flat. When we sped it up, because again, it's an asynchronous operation, you see that the pool, how full the pool is, shrinks back down. So I've deleted the file in the NTFS file system. Server 2012 is issuing these SCSI commands saying, I don't need this anymore, I don't need this anymore. The array grabs that SCSI command and unmaps that on the back-end storage array. So this is thin provisioning that can now shrink back down, which is obviously pretty cool stuff. Now I'm going into a VM. So that was on a Server 2012 parent host. Now I'm going to go into a VM to show that unmap commands actually work within a virtual machine as well. So I'm going to a virtual machine in my Hyper-V environment, and I'm going to add a disk to it. So I'm adding a virtual hard disk. So I'm going to browse for that, pick up my one of those thin volumes. So these are the very same ones we were looking at. We were just on the parent before. And I'm going to pick up one of those VHDXs and add it to the VM. So we've added that guy to the VM, and just wait for it to, I'm going to have to go make it pop up. Let's go over to disk management, and we'll see that guy pop up there. Bring it online. And we have our VHDX file in our VM. Now we're going to open that guy up, and we have yet another backup that a DBA has done, 226 gig file that backup is, and I'm going to delete that. So very similar to the operation we did before, but I'm deleting it now within the guest. And what we're trying to show here is the guest does the delete, and those unmap commands are passed up through the hypervisor all the way back to the storage array with a VHDX file. And you can see on the left here that, again, the pool is shrinking again. So I've deleted another 300 gig file from the pool, and it's shrinking down. So really awesome technology for thin provisioning to be able to shrink these pools down, because I've seen a lot of customers use thin provisioning, and they end up with stranded space in file systems where they've deleted files out, and they couldn't get it back. So just showing here on the optimized side where you can run it manually. First of all, you can see your thin volumes, and you can see the space efficiency on it. So whether you need to do the unmap operation, you can do an analyze on it. It's doing an analyze here. It's going to come back with the same thing, 100% space efficient, because everything's been unmapped. You can click optimize at any time to do an unmap operation at a later date if maybe you disabled it on that host and you want to run it at a later date. So, yep.
In the same way that thin provisioning is passing up and working inside a virtual machine as well, does the same apply to ODX?
Sorry, can you repeat that?
So in the same way that you've got the file within the virtual machine taking advantage of unmap.
Yep.
Oh,
yeah.
Data transfers inside
Yep.
the virtual machine.
Yeah, both ODX and unmap will traverse through the hypervisor as long as it's VHDX. So, yeah. And I don't think I didn't show one for ODX that way, but it will work. So that's a bit on that. Unmap, so operational behavior. Again, it's very ODX-like, so you don't really have to do anything with it. Some warnings on it. It can serialize I/O operations. If you do massive amounts of deletes, it's got to send those commands down to the storage array to do the unmap. Microsoft wrote a hotfix for this to reduce the impact of that. So you shouldn't see serialization based on that if you have the hotfix on, but that's a bit of a warning there to check out that hotfix. It's quite new. And a telltale sign that you're experiencing that is if you have things that appear to stall slightly in the file system. So just something to keep your eye out for. The control, again, not much to do with it. You can disable and enable unmap. It's on the host layer, so it's just on or off. So pretty simple stuff, except that it's a weird naming convention there. It's set, disable, delete, notify. It's sort of opposite thought, but that's how you do it. Answered this one already, Hyper-V support. Both operations are supported completely in Hyper-V as long as you're using VHDX. So they are traversed through the hypervisor. It will obviously work with virtual HBAs as well. Is anybody using virtual fiber channel at all yet? No. In case you didn't know it existed, Server 2012 added support for virtual fiber channel. The HBAs have to support it. Basically allows you to have a fiber channel connections directly to the VM. So sort of like direct access to LUNs with fiber channel adapters right in the VMs. So good technology for things like guest clustering in Hyper-V, but it's supported with that as well. Okay, we need to have a little bit of a break for a second, so we have to have a trivia question. I have a $20 Visa gift card. Whoever says the answer first can have it. What does ODX stand for? Whoever is here. Okay, on the Windows storage management. So we covered Unmap and ODX. A bit on storage management. So in SCVMM, Microsoft did a lot of work on storage management. They implemented support for SMIS, so standards-based discovery and management of storage. What does this mean? It basically means that you can treat storage very generically with Hyper-V and SCVMM, which is a good thing. So if you have more than one storage array type, whether it's a couple of EMC arrays or you're multi-vendor, you can treat all those from a management perspective all the same. So it's good for the management experience. So have a look at what this means. So if I look at SMIS and how it's implemented, first of all, there's a great PowerShell kit that you have with it. So you can go get module, SMIS config, so I can see all the commands that are available in SMIS, and I can have a look at some of the commands. So I'm going to look at very specifically the SMIS config, and really the most important one is the storage one within that. So I'm going to have a look at that and all the commands that are available. And what this allows you to do essentially is write PowerShell scripts that can do the same thing for any storage array and reuse that script, right? Because it treats every storage array the same. So I look at all the functions that are available in SCVMM and all the common stuff you would do with storage, like creating LUNs, resizing them, creating snapshots, all sorts of things. So here I'm running a get volume command, basically see what volumes I can see on the host. But everything is totally abstracted with this, so very, very standards-based approach. Now I'm doing a get storage provider. I see two storage providers down there. I see the native storage spaces one that's built into Server 2012, and I see our storage provider. So what we have to expose to SCVMM is an SMIS storage provider, and that's the gateway to the storage arrays. So what I'm going to show here is a PowerShell script that provisions some storage. And again, the really cool thing about this is you could reuse this script, whether it's EMC or some other storage vendor type of SAN array, as long as it's SMIS compliant, right? So if they have a provider for SCVMM, the script will work. It's all standard commands. So we have a very standard script here. It goes through at the top. We put in some of the details of the array. Down at the bottom, you're going to see some of the important bits. So really what we're trying to do is create a new virtual disk. A virtual disk is the LUN we're giving to the host. So pretty simple stuff there. Go back up to the top. I can see where we set some of the specifics for the script in PowerShell, so I can just execute that. Let that go. That's done. I'm going to register the provider. So I see our SMIS server that we've installed for our storage array. Done that. We're just stepping through it so you get an idea of what how it works. Get the storage subsystems. Now I can discover the storage subsystem that's attached. I can go through, get the storage pool on the array. So that's pretty cool stuff. And the next one is getting the masking set. So how LUNs are attached to the host. And then finally, we can get to the spot where we actually create the LUN. So we run that line there. We're going to create the LUN on the storage array. So now it's actually talking to the storage array, creating a LUN on the storage array. So this one actually takes a couple seconds to run. And it's done. And then the last but not least, the last step we have to do is actually give access to the LUN, so a masking operation. Now remember, this is all done with standard PowerShell commands. I don't even have to crack a manual for the storage array platform, which is kind of cool, or know how to use the GUI, or know where the GUI is. Go back to the host over here, and I will do a rescan, and we'll see our disk pop up. And there's our 44 gig disk that we created, and away we go. So we can, bring it online and do everything with it. So that's a bit on SMIS. Now, that was pretty cool. You know, you can do some pretty standard scripting with multi-vendor storage arrays, but not everybody wants to do that. So how do we simplify that even more? So System Center Orchestrator, anybody used it? It's pretty cool. We have runbooks for System Center Orchestrator. So Orchestrator is a tool that allows you to basically drag and drop and create runbooks to do actions within your environment. So have a look at what that means. So we're going to launch Orchestrator. So again, and we're thinking of the context of SMIS here. We have some runbooks. And we see on the side, we have all these activities, and there's some that come with it. There's activities that can get added to it, like for Virtual Machine Manager, for all sorts of different products. We have one from our partner Cisco for doing, server-level operations. But you can see here that we can start drag and dropping operations. So initialize data operation. Now I'm going to our integration pack, and we have all these different things you can do, like create a LUN. Pretty common thing you might want to do on a storage array. Maybe you want to present that LUN to a host after you create the LUN, right? So think of these as what I did in PowerShell, but all as little commandlets that are all bundled together. So anybody can do this, literally drag and drop, connect those operations together. So initialize data, create LUN, present LUN to host, and initialize host disk. So look at the operation of it. And we see pretty simple stuff. I can go through all these guys. And the only thing we really have to do with this operation is give it some data. So here's the data you can input in. So things like host name, array name, how big I want the LUN to be. Obviously, I need to tell it that. It can't guess what I want. And you can see here that it links those back on the create LUN property. So when I go to the initialize pane, it takes the data I give it, and it'll link that back to the create LUN. So we're just going to run a bit of a test on this. So we're going to open that up so you can see the whole operation that's going to happen. And going to run that. It brings up the initialized data properly. So host name, what host I want to hook this up to, where do I want to give my LUN out to, what array, so it's one of our VNX arrays. How big do I want that LUN? 60 gig. What storage pool do I want it to come from? So I have a Hyper-V storage pool. And what friendly LUN name do I want to give it, so I know what it is when it pops up, or if I'm in the array, I can figure out what it is. So you put those few simple bits of information in there, and basically it's going to go through and run through the activity. Again, now that you understand how SMIS works with SCVMM, under the wraps, that's how it's doing all these operations to the storage platform. Yep? I don't think we can do that yet.
There's PowerShell commandlets for it, so there's not activities within the integration pack, but there is PowerShell commandlets that come within the same pack, the same installation. So you can just palm off to any sort of snapshotting capabilities as well.
Yep. Thanks, David.
And replication and recover point.
Thank you. No, that's good. Now you see here, it's all done. The difference here from the previous demo is I created a LUN and attached it to the host. Here I've created a LUN, attached it to the host, and formatted it, initialized the LUN. So I've done the whole operation, right? But very, very easy without writing a single line of code, right? So that's the power of Orchestrator. And then you can imagine linking this in with other integration packs, like I said, our partner Cisco, David's got some great ones set up where he can do bare metal builds of Hyper-V hosts. So you can bring the bare metal host online, get Hyper-V installed on it, and then bring up all the VMs on all through Orchestrator. So it's pretty cool stuff, all without scripts. Some other integration for SCVMM. So I talked about the SMIS, so passing those commands down to discover the storage array. We can also do some other pretty cool things with SCVMM and SMIS, and it's working on discovery of the storage array. So we've looked at the script, we've looked at Orchestrator. Now let's look right into SCVMM. So there's a storage pane on the side. Again, I'm going to look at the providers. There's our SMIS provider that is the gateway to the storage platform. You're going to need one of these for each vendor that you have in your environment. So if you have another storage vendor, you're going to need another SMIS provider configured. For EMC, one will work for all our storage arrays, so you only need one there. You can see there's a couple EMC storage arrays in the SCVMM environment. You get lots of great information. Again, I don't have to log into the storage array or any other GUI. I can see the capacity of the array, how many LUNs are on the array, all sorts of things. How many pools are on the array. You get tons of information, as well as I can see the number of managed pools. And what a managed pool is a pool that I've allowed access for. So this is really important. So this is basically delegation. So I see some of the pools on the array. I've created up some classifications, and I see a fiber pool. And in that pool, I can see all the actual LUNs on the array. So it's just discovering that through SMIS. Pretty cool stuff. I can see some other, just scrolling around here, looking at all the different pools on the array. And I can see the classifications that are set up. So I have a fiber channel pool and a flash pool and a SAS general pool. So some neat things we can do here on the delegation side. I can look at the very same cloud that I had before, my Cloud 2 servers, and look at storage. And I can see that I've assigned a very specific storage pool to that cloud. And this is delegation. So that means that I can only use storage from that pool for that cloud of VMs. So really cool stuff there. I'll go back down to that cloud. I can see the dev QA. So that's the one I was working with before. And I'll do a properties of that guy as well. And again, you can go down to the storage tab there and see that some delegation was done to a very specific pool. Now this could be multiple pools. If I want more pools for that cloud, no problem there. And last but not least, very powerful feature of SCVMM, I've created a tenant. So a consumer within the environment. If I look at that tenant, I can set quotas for that tenant. So I've gone through and I said that tenant uses, in this case, the production cloud. And I look at the quotas and I can see that I can set all sorts of quotas for that tenant. Very specifically here, storage. So I can set limits on it. So not only can I restrict who can use what in terms of what pools in the storage array, but I can also restrict on how much they use, all through native SCVMM functionality. So built into the product. Really, really cool. Just another last feature on SCVMM, VM creation from templates. I said before, it uses bits transfer. So if I have a template in a library and I go to create a VM from it, no matter what, it's going to use bits at the current version, even if the array is ODX capable. In R2, that's going away, so you'll be able to use ODX with that. But there's another really, really cool feature, and it's called rapid provisioning with SandCopy, and that's the ability of SCVMM to use array-based snapshots and clones. And this is a really good use case for development environments. So I might have developers that want a VM temporarily copied and do some work on it. And I don't want, I just want it instantly. I don't want to keep it around a long time. Great use case for this type of technology. So I'm going to go to the provider again. You all understand SMIS now. I yet again see the EMC provider. I'm going to go to one of the storage platforms. So I'm going to highlight, I think it's the VNX I highlight here. Yep, go down to properties. And I'm going to go under settings. And I can say use snapshots or clones on that array. I'm going to use snapshots because they're space saving. Again, I don't have to know anything about the storage platform. I go to my library host, And I open up, we've got a couple library servers here in our environment. And I'm going to expand them out. And I'm going to look for one of the template files, highlight it. And if you look at the bottom, I see here that send copy capable, no. So this is a LUN that's not sitting on a, that's not capable of being snapshotted or cloned. This one here is. So the SCVMM is automatically detected that I'm able to snapshot it. I've logged into one of our storage platforms just to show you. I go down to data protection snapshots. There's a few other snapshots from other operations, but nothing else. So just to show you. But again, you don't have to go into this. This is completely from SCVMM. I'm going to have a look at the template file. There it actually is. So that's that LUN. It's a single VHDX per LUN to do the snapshot, do properties of it. And I can see it's a 45 gig LUN there. So that's my image that I'm going to create my development environment from. So I'll close that up. And I will go back over to SCVMM. And basically what we're going to do is do a bit of a bake-off here, have a bit of a race. So I'm going to provision a VM, traditional style. So go back to that template, create a VM from it. So create new virtual machine. So, and this is the one that says send copy no for not capable. So it's going to use a bits transfer. We're calling it slow. It's not bad. It's just going to go slower, obviously, because it's going to go over the Ethernet network. Just set up a few of the bits and pieces here to get the VM up and running, get the networking set up. And I'm going to place it on a host within the cluster. Now, both VMs that we deploy, we're going to place on the exact same host to sort of keep it as even as possible. And we're going to start that guy up. So choose the CSV it's going to sit on. And away we go, create. So that's getting kicked off right now. So I see create virtual machine. If you look down at the bottom, you can see all the steps it's going to go through to create that virtual machine. And that line there is the big one. It's just started. So it's copying that entire template over the Ethernet network down to that CSV. So it's pretty standard stuff. And it's going to complete in 19 minutes. It's going up, actually. So something must be busy. So 20 minutes to deploy one VM with standard bits transfer. Now I'm going to go create virtual machine on my send copy capable one. Now this one's going to use a snapshot in the back end instead of actually copying the data. So I'm going to go fast on that one for the machine name. Choose all the same things. So give it, it's essentially a duplicate VM for every other setting. And again, place it on the exact same host within my environment. So select that host and let that guy finish. So deploy that one out. And you can see there, the transfer type is SAN, not bits. And give it a path. Now the path here for the CSV is just a mount point because it's literally going to mount up the snapshot on the CSV within there. And create, and away it goes. Now we've got our race going. So I see the other one started. I go back to my other one. It actually says it's going to take 25 minutes. It actually went up in time. I guess the network got congested there. So it's a drawback of that. So it's going to take quite a while for that guy to complete. Now I go up to my send copy based one. You can see create virtual machine. It's doing rapid deploy using send copy. So it's actually creating the snapshot on the storage array right now, again through SMIS, so standards-based approach. Doesn't matter the storage array type as long as it's compliant to SMIS. So it's creating that snapshot on the storage platform. And you can see that it's already done creating the snapshot, so it's essentially done the copy. I go over to the storage array, hit refresh, and there's a snapshot there that SCVMM created. So nobody logged into the storage array to do this. Again, SMIS. There's my snapshot on the storage array. Go back over to SCVMM. My slow is still going, 21 minutes left. This guy here is going. So they're tied. Oh, I'm ahead. Basically, this job, you'll see it's going to complete in a few seconds here. There it goes. And you can see in the bottom left, it completed in 1 minute and 18 seconds for 45 gig VM. About a minute of that was all the steps to provision the VM. There's just a few seconds to create the snapshot. So a really, really, really fast way to create quick VMs. Again, in the context of development environments, I need lots and I need them fast. So this is the last little bit. So SCVMM extreme performance. Thought we'd show you something a little bit fun to finish it up. What can we show you with extreme performance with SCVMM? VDI. Who's doing VDI? Anybody got some VDI infrastructure? Who has an undersized storage VDI infrastructure where it's really slow and painful? Yeah, it's very common. VDI is typically high I/O. People think, oh, desktops don't need a lot of I/O. We can run it on nearline or SATA drives. Typically, we see they're very high I/O and they're difficult I/O profiles. So 50-50 read-write ratios. You add to that boot storms, users come in after a long weekend all at the same time, all log in at the same time. You have massive I/Os on the storage platform. And then you add on that in-guest activities, virus scanning, and all these things. And then you got to tune it and try and drive down the I/Os because it's undersized. Very, very common. What we're going to show you is a bit of an eye candy demo. We're going to spin up a whole ton of VMs. In fact, this is on 3 Cisco blades, half a terabyte of RAM. We ran out of RAM. So 750 desktops, so quite a large number of desktops. We're gonna turn them on in a second. We've logged into a storage array that we have that's all flash. So this is a deduplicated all flash storage platform, perfect for VDI. It's called Extreme IO. And David's written a script here that basically will power up all those VMs all at the same time. So 750 desktops, a lot of desktops, right? So those guys are all powering up. So again, on actually it was 4 Cisco blades, B200 blades that it's on. And you can see the array starting the workload that the desktops are generating. And now this is good data because this is real workload, right? This isn't an I/O generator. This is 750 real desktops powering up. And you can see generating 70,000 I/Os a second, so a pretty hefty workload. This is not shortened in time. We're going to search for running, and you can see 336 of them have already booted in maybe 10 or 15 seconds off the all-flash storage platform. So I've booted up half of them, and this is a massive boot storm. And you can see the massive amount of read workload. It's mostly reads out of those 72,000 I/Os until those guys get up and running. If we had real users, once it's settled and you had real users, you would see that read-write ratio change to get a lot more writes, but on boot up. And we're just going to have a look to see what one of these guys looks like. Open it up. And we didn't even cheat because if you look at the desktops, they're Windows 8 with Office 2013, which are the worst ones because they generate the most workload. Not worse in a negative way, but they're the newer ones. You got to be careful. Yeah, you can see it's completely booted up to the desktop. So pretty cool stuff. That's all I wanted to cover. Basically, what I wanted to show you is basically driving some really cool efficiencies on the storage array layer and leveraging storage array platforms with some of these integrations and being able to scale in different environments. So hopefully walk away with some good tidbits. If you want to see more of this, come by and see us at the booth. We can do all this stuff live through our VPN connection, stuff I wanted to do here live, but just a little risky. Also, this URL, demoit.me, it's public facing. We post a lot of recorded demos like this up there, so you can just go download them, have a look, ask for us to record one. So feel free to do that. Really appreciate your time. Jo is going to just wait 1 second. She's going to do a draw for a $50 gift card for your patients. Should I do it?
Yep.